Howdy, everyone. Please join me in welcoming Professor Herman Chernoff, recipient of the 2022 Emmanuel and Carol Parzen Prize for Statistical Innovation. Although he, of course, doesn't need any introduction, I shall briefly go over his biography before commencing the question and answer session. Professor Chernoff received a PhD in applied mathematics at Brown University in 1948 under the supervision of Abraham Wald at Columbia University. He completed a BS degree in mathematics with a minor in physics at City College of New York in 1943 and an MSc in applied mathematics from Brown University in 1945. He joined the statistics faculty at Stanford University in 1952, and he was professor in 1956. Professor Chernoff served as department head at Stanford from 1971 to 73. Later, he joined the MIT mathematics faculty in 1974, and he left MIT in 1985 to join the statistics faculty at Harvard University, from where he retired in 1997. His research contributions are enormous and would take probably all the time to summarize and go over his research contributions. So I'll be very brief. Ranges across a wide variety of fields, including statistical decision theory, design of experiments, sequential design, multivariate statistics, large deviation theory, just to name a few. His service to the academic community in research and education has been extensive. He has served on the editorial boards of the Annals of Mathematical Statistics, Siam Journal of Applied Mathematics, Journal of Statistical Planning and Inference, and Sequential Analysis. He was a member of the Mathematics Advisory Panel of the National Science Foundation from 1962 to 65, and served on the Council of the Institute of Mathematical Statistics for a long period of time. He was president during 67 to 68. He also served extensively on research committees of the National Research Council, statistics visiting committees of both Harvard and Stanford universities. He received honorary doctorates from Ohio State University, the Technion, University of Athens, and the University of Rome. He is a recipient of the Townsend Harris Medal and the Samuel S. Wilkes Medal. He is a fellow of the American Academy of Arts and Sciences and a member of the National Academy of Sciences and of the International Statistical Institute. He was also a fellow of the Association of the International Statistical Association and the Institute of Mathematical Statistics. So please join me in welcoming Professor Herman Chernoff again, and we shall now begin. We have a list of questions, so we'll go over those, and like to share his thoughts on the questions we have received. Shall we begin, Professor Chernoff?
Are you ready to start then?
What's that?
They want to know if you're ready to start.
Oh, yeah, I'm ready.
Thank you.
Yes, Herman.
Thank you. So given it's the occasion of the Parzen Award, I'd like to start out with the question which asks about your long overlap with Emmanuel Parzen at Stanford. So great if you could share some memories of him and if there were any research overlap between you and him.
Yeah. I had the pleasure of appointing Dr. Parzen to the Stanford faculty because he had just graduated from the University of California, and he was available, and we saw him as a good choice for the statistics at Stanford, and I picked him, and he came, and he was my next door neighbor. While we were at Stanford, we were in adjoining offices, and we often had occasion to talk, although we didn't overlap very much. On occasion, we did work on similar things, but mostly he was in probability and I was in statistics.
Yeah.
Incidentally, is a great honor to get this award, and I appreciate it. And thank you.
Thank you. I have a couple of questions related to your PhD days. The first one is an interesting one. It says you got your PhD from Brown. Your advisor, of course, was Abraham Wald from Columbia. So how this long distance thing worked out in there, no internet and everything.
I wrote my thesis in absentia, and that involved going to Columbia and working there under Wald in January of the year, one of the semesters I was there. I asked Wald if I may come as a student of his, and he was rather reluctant, but it turned out that I had published my master's thesis, and so he was willing to accept me provisionally. And so I became a student of Abraham Wald, who I regard as one of the outstanding statisticians.
That's amazing. There is one more question about Abraham Wald. So we already spoke a little bit about him. If you could tell us a little bit more about Wald as an advisor, the colleague, and his impact in statistics.
Well, I came to Wald and I had some high theories about how to do statistics, and he shut me down and said, why don't you learn a little statistics first? So he made me take some courses there, some of which I was familiar with and some of which was new. And they had a very good staff, although it was small. In those days, they had about 4 assistant professors.
What was an example of something that you didn't know that you have to learn?
What's an example that I didn't know? Well, I was new to the field of statistics. I had been impressed by a paper that I came across the previous year that he had written. It was a very modest sounding paper. It was a generalization of testing hypothesis and estimation. And he put those 2 major topics in one field. And he just called it a generalization. He did not call it decision theory at that time, but it was obviously an important thing. And it came out about the time that game theory had hit. And it is obviously an example of game theory where the players are the statistician and nature, who you don't understand. And that paper seemed to me so obvious that it wasn't a great oeuvre, but it was also obviously a rare insight into statistics that had been neglected in the past. With the theory of testing hypotheses by Neyman and Pearson, they had made a great advance by saying you have to consider alternatives to the hypothesis that you're testing. And to me, when I read that paper, which came to me because my undergraduate teacher was taking a vacation for a week, and he gave me a paper to read, and that was this paper. And it also was something that was so obvious that you didn't think it could be that important, but on the other hand, it was obviously a very important step in the philosophy of statistics.
Absolutely.
And decision theory. In fact, during my years in college, I had decided, because of another statistics course that I happened to take, that if the academic interest in statistics was what that course was telling me, I would never take a statistics course again. But just by accident, many years later, I came across this paper and it converted me. So I decided to give up my other fields in applied mathematics and go into statistics.
What were your other fields in applied mathematics?
Well, there was fluid dynamics, and my brother-in-law was saying, what are the other fields of applied mathematics? There's fluid dynamics, and which was one of the main objects of the program at Brown University. And in order to do fluid dynamics, you had to do complex variables, you had to do
Some other.
I must hesitate for a minute. I have a problem with old age. I forget certain words that were very prominent in my application, but I can't think of a particular word at a certain time. And you'll forgive me, but it's old age working on me. So I'm not going to list all the other courses that I took, but there was I forget a simple word evades me sometimes.
That's this is
So
Anyway, you got away from it, so it doesn't really matter.
okay, so is there anything else?
Yeah, they have a lot more questions, Daddy.
What are the questions?
No, so just as a follow-up to your PhD days, I was curious how regularly or frequently you interacted with your advisor, or were you very independent from the very beginning? So if you could comment on your mode of working in your PhD days.
Did you hear that, Jim?
Excuse me?
Did you hear that?
What?
Did you hear his question?
No, I didn't.
Oh, he wants to know how often you interacted with Wald.
How often I what?
Interacted with
Oh,
Wald.
Wald died.
You know, when you were working on your PhD, did you see him daily?
Oh, with
or-
Wald, no.
Yeah. Did you work on it independently?
I was taking a lot of courses, and I saw Wald maybe once a week or once every other week. He gave me a topic to work on, and I wrote my thesis on that topic.
Did you show him drafts of the thesis as you were working on it?
No, I was working on the thing, and I told him that I was making progress, and I made progress.
Oh, really?
When did Wald die?
He died
we
in an
has
airplane accident.
He died in an air crash.
Yeah.
During this period?
No, after that. he
Oh,
so can I?
He died after you left.
When
oh.
They asked when he died.
When
He
he
died
died.
after you
Oh,
left.
Wald died in early 1950s.
Yeah,
Mhm.
Coming back from
And
India.
I got my degree in 1948. Went to the University of Chicago, where they had a program called what was the program? It was what
No, the economic course.
in economics. There was a program called what was it called the
Coles Commission.
the Coles Commission
For
for
economics.
research in economics, and there was a group of people of whom 3 or 4 became Nobel laureates in
Mm.
economics. One of them was hadn't had his PhD yet, but he was obviously brilliant. His name was Kenneth Arrow, and he was one of the young people there.
And your boss, Coupons got it.
Yeah, well, there were others, but there were several of them that got Nobel laureates in economics. And at that time, I wasn't particularly interested in economics. Now, in my old age, I'm reading about economics, maybe.
Mhm.
So I didn't get to see much of Wald, except when he taught. He was a teacher, and he taught a course in analysis of variance.
Mhm.
Analysis of variance was basically a very simple course for an advanced mathematician. So it wasn't very difficult for me. But it turned out that let's see, I had a senior moment. What was the thing that I was going to say about analysis of
you
variance?
said it wasn't a very difficult
What?
course.
It wasn't a very difficult course. But at Stanford, someone came in who was sponsored by the government. He was only going to be there a year, and he wanted to take the most advanced courses possible. So I gave him 3 pretty heavy advanced courses to take.
Uh-huh.
I thought for a 4th course, he should take an easy one. So I gave him the analysis of variance. It was the 4th course he took. It turned out that 4th course was taught by Charles Stein. Now, Charles Stein was a magnificent statistician. He was called the well, I forget what he was called, but he was who's the great mathematician? Oh well, anyway, he was called the outstanding mathematician of statistics, and when he gave the course, and I examined the student a month later, and I said, "Well, how are things going?" And he says, "Well, I'm taking real variables. That's measure theory, and that's going okay. And I'm taking advanced probability, and that's going okay. And I'm taking a decision theory, and that's going okay. But I don't think I have the background for the course in analysis of variance." And and I was amazed. Well, the problem was that Stein, he taught the analysis of variance from the point of view of
mathematical.
no, he taught it from a very abstract point of view, mathematically. And most of the students had no idea what he was doing at that time. In fact, Stein was effectively a very good teacher, but he was a good teacher for our visitors, and our visitors were people who had PhDs in statistics and were very advanced and they could penetrate some of his thinking. But for a student without the right background, he was hopeless at that time.
Yeah, it's amazing to hear about. So you talked about Charles Stein. Any of your contemporary statisticians you'd like to talk about briefly?
Judy, Ellen, Miriam,
Yeah.
Can you translate what he said?
He wants you to talk about other contemporaries who you were impressed with.
Oh, well, one of my contemporaries was Charles Stein. Another one was Sam Carlin. Sam Carlin came with a background in mathematics, and when he arrived, he says, well, I read about multivariate analysis, and I mastered that subject in a couple of weeks. Now I'm going to do what's the subject where you do testing hypotheses where you don't have a
Non-parametric.
what non-parametric statistics. He's going to work on non-parametric statistics next week, and so he attracted a lot of students. He was very aggressive in getting students and getting them to work on his problems, and he did very well. Another person was another person was Al Bowker. Al Bowker was the chairman of the department. He had a relationship with Fred Terman, who was the provost of the university, and they had decided both to attract funding from the government and to build up statistics. So Bowker started the statistics department with Fred Terman's help, and Fred Terman essentially was the mastermind behind the growth of Stanford University. He organized it so that it would become a great university. And it was a good college before, but it wasn't a great university at that time. Then there was Herman Rubin. Herman Rubin had the incredible gall to tell Bowker that he's a dope. And Bowker didn't appreciate that. So fondly, Bowker saw to it that Herman was not promoted. But Herman Rubin was a genius. He could go to a lecture, listen to the lecture by a mathematician, and absorb everything they told him. And when questions came up and said, how do you generalize that? And the speaker would say, well, I thought about it, but I haven't figured that out. And Herman Rubin would tell him, he'd say, oh, you can generalize that easily by doing such and such and this and that. And he could think very fast, and he could think straight, and some of his thoughts were very good. It was my custom when I was working on something to say, I'm working on this problem, and I think I'm going to attack it in such and such way. And he would say, that's the worst possible way you could do it. And I would stick to my guns, and I would say, well, what's wrong with the way I do it? And after about 15 or 20 minutes, he would admit, well, maybe this is this is a good way to look at it. And we wrote a couple of papers together.
Mhm.
And
Don't go into it.
he
Well-
deserves a lot of credit for his ability to see things clearly and tell people what he sees.
Mhm.
Now, who else? There was Bauka, who was the dope, and
You wrote down all these people, I think. No? Okay.
Lemon.
I listed people who were important in statistics. Well, some of them were very important. Were R.A. Fisher, I regard as the giant in the field, and Wald and Neyman were very, very important people in developing the field. And
Oh, yeah, that's
Yeah.
great to hear about. Kind of related question. There is one question about your notable PhD students and how you influenced each other.
Miriam, you have to translate for me.
Question about your PhD students and how you influenced each other, how you
Oh.
worked with them, and
How did you work with it?
can you remember?
I'm not sure.
Who were
It was
Yeah.
hit and miss. There were a few students who were very good and could work with me. Others had to work by themselves and take some supervision, but they were generally quite
Can you
good
remember?
students because we had a select group of students. One of the outstanding students was who's the one in the retirement home, the one who sold his mansion? Pratt,
Crap.
Bill Pratt.
Mm.
He was very modest, and he ended up in the business school at Harvard.
John Fred.
But he was a brilliant person.
John Fred.
What?
John Pratt.
John Fred.
Mommy said his name is John.
Not
John Pratt.
Yeah.
John Pratt, yeah. And another one was yeah, I'm forgetting names. So
Howard Reed.
I'm having trouble.
Uh, there,
It's that those names are hard to remember. It's just
Mhm.
right now, because of my mentality.
Tell them about Gaiman.
About who?
Gaiman.
Gaiman. Oh yeah, Gaiman was one of my students.
Mm.
And what happened is he came into my office one day and put a manuscript on my desk. And he said to me, I have to get my PhD this year, or my parents will make me go back to medical school. And that was the first I saw of him. Now, I think he was the victim of the man who was in charge of applied mathematics at MIT. This guy said, don't bother the faculty unless you have something of interest to them. So he had gone off into a corner and worked on a thesis. And when he finished it, he put it on my desk and he says, and now I want my degree. And his name is Stuart Gaiman.
Mhm.
It turned out he didn't know much about statistics. He was like I had been several years earlier, ignorant of the basics. So I and one of my visitors my visitor was the guy from
Woodruff.
Michigan,
Woodruff.
Al Woodruff. Sort of decided to give him the background that he needed in order to make sense of his thesis. His thesis was sort of plebeian at that time, but not quite good enough to be accepted. And we worked with him for half a year. At the end of that half a year, I had to go on my sabbatical. And so I left Woodruff in charge of him. And then I came back 3 months later and oversaw him. And by the time we were finished with him, he had a workable thesis. And he got his degree. But he got a job in Providence at Brown University. And at Brown University at that time, there was a statistician from Switzerland, from
Grenander.
Yeah, his name was Grenander. Where was he from? He was,
Sweden, I think.
well, Sweden. Yeah, he was from Sweden. And he was a very good statistician. And I think he sort of finished up the education of my student, whose name I forget.
Stuart Gaiman.
Stuart Gaiman. And Stuart Gaiman and his brother, who was a PhD in English literature, wrote a joint paper which turned out to be important, an important paper in statistics, how to maximize things, etc. And so that's two. Well, I had a lot of individual students that I can't talk about. Now, one of the questions was about one of my students,
Jay Cadane.
Jay Cadane. Now, Jay Cadane, the first year he was at Stanford, he didn't pay much attention to his coursework. He was mainly interested in politics. There were several issues there, and he dragged Stanford University into the 20th century, because until that time, Stanford had several customs which were so strange. For example, a person playing sports had to wear a certain outfit, and no ponytails were accepted. Well, one of their scholarship students for the sports thing was a racer from Britain, and he was going to have his ponytail no matter what. And the second problem they had was a woman who had been married could not live in the dormitories, whether or not she was still married. Why? Because if she lived in the dormitories, she would be a non-virgin, and they could not have a woman's dormitory with non-virgins in it. And third was religion. Every religious sect had to have their services in the main cathedral there. And he was insistent that certain Christian sects were important to have their services somewhere else. So he arranged so that every Christian sect that needed separate services would have them in a particular place on campus, not necessarily the church.
No.
And these were just a couple of the things that Jay Cadane arranged in his first year. He came to his second and third year. I'm not sure what his background was, but one thing I do remember is that he did not know about certain basic things in statistics. He had to be educated a little bit. But he wanted a thesis on a subject that had to do with economics. At this point, I dredged out a problem that one of my coworkers had worked on, which was that they had a very fancy way of doing their analysis of a procedure, and to do the equivalent of linear algebra. We seem to be having a telephone call.
Here, I'll take it.
It means that even though I'm busy with this thing, there are other things going on. Well, what was I talking about? Jake Cadane? Yeah. So I dragged out this problem that ordinary least squares did a great job on things, but if you did this fancy thing, you got peculiar results. So I decided that the problem with this was that if you consider that the errors in the straight line fit were small, very small, you would have different results than if you just do these squares. So I had him work on that problem, and he wrote a very nice thesis on this issue. Later on, he got an appointment at Yale, where he came under the influence of Jimmy Savage. Jimmy Savage was the master of the American master of
Bayesian statistics.
Bayesianism. I take the credit for telling him to work on Bayesian. But what happened is that until then, Jimmy had decided that the criterion for decision theory, the minimax criteria, didn't make sense. There were situations where someone would do something very stupid to avoid doing something else. And it just didn't make sense. And he thought that he had a solution to this problem. And he solved this problem by saying that you shouldn't minimize the maximum, you should minimize the maximum regret. Not the maximum loss, but the maximum regret. And the regret is the difference between the actual loss and the best that can be done for that situation. Well, that criteria, I was teaching a course at another college nearby, and I gave that as an example. Then I thought about it, and it turned out that method didn't work. And so I told Jimmy Savage, your method doesn't work. And he argued with me a bit, and then he finally admitted it was wrong. It doesn't work. And he says, I guess we should use De Finetti's principle of Bayesian analysis. And so he decided to work on Bayesian analysis, and he wrote his book on it.
That's really fascinating.
So I claim that I spurred him on to do this. Incidentally, I'm not a Bayesian myself. And my theory is, as far as statistics is concerned, scientists should be both, should consider himself from a Bayesian and a decision theory point of view to understand the problem. Once he understands the problem, it's not necessary to attack it as a Bayesian, because that can give you trouble. Because who can find the right prior in a multidimensional problem? It's impossible. And so my theory is, you understand your solution from the point of view of a Bayesian. How does it fit as from a Bayesian and a decision theory point of view? Otherwise, you don't understand the problem, and what you're doing might be junk. It might be very valuable. Who knows? And so that was my theory thing.
That's fascinating to hear about. I had to ask this question about your own research, and there are a couple of questions. The first one is about, where did the idea of the Chernoff faces come from?
Oh, that's interesting. I spent a year as a visitor at MIT before finally deciding to come there. And one of the things that was of great interest at MIT were some professors who were working on artificial intelligence. And they had written some papers and were very heavily involved in it. And I thought at that time that I would propose this method to show that the artificial intelligence has a long distance to go to catch up to the human brain. And I used the faces for that purpose. Now, there have been other variations of it, and some very simple, some very complicated. I myself very rarely use faces, but I think it has potential to show that something strange is happening. And you can, if you have multivariate data, you plot the faces, and if the faces look screwy, then there's something going on. You should pay attention.
Tell us what you mentioned before, the relationship between literature and statistics.
I need some translation. I'm not going to.
You mentioned that.
One person was a statistician, the other person had a PhD in English literature. But I didn't understand the connection between those two fields.
No, it was just that the brother,
Yeah.
they helped each other write paper.
But
There wasn't a connection.
there wasn't.
No.
Okay.
We're having a conversation back here.
Absolutely.
It's probably more interesting than but I don't hear that well, so I have to have them translate for me.
About your research, if I could ask, so we talked about the faces. Another, if you could, among your many interests, if you could talk about one other topic that's very close to your heart.
Well, I once hit the newspapers because of a paper I wrote on how to beat the Massachusetts lottery game. And that was before there was a real way to take advantage of the lottery. They changed the rules a little bit. I wasn't paying attention anymore to that thing. But early on, when the game had been played about 300 times, the graduate student at MIT or undergraduate at MIT found that there was something peculiar about the payoffs. And oh yes, he had asked an officer, how often does the same 4-digit number come up in your experience? And the man said, oh, very, very rarely, because there are 10,000 possible 4-digit numbers, and you would never expect it to happen. But it turns out that there's a problem called the birthday problem. And according to the birthday problem, you expect it to happen about 7 times. And I went to the chairman of my group and I said, what should I do? As a public spirited individual, I should emphasize the fact that the lottery is crooked or is not working well. And he advised me, he says, find out how it's ruined and then take advantage of it. So I asked for the copy of the 350 4-digit numbers and the payoffs. And looking at those numbers, it was quite obvious. The numbers 7890 very rarely showed up in among the winners. So the people who had bet on 7890, they would win a lot of money because it was a pari-mutuel system. So the money that was allotted for the victims, for the bettors, would be distributed to the winners of this thing, and the winners would get a lot of money if they had bet on 7890, and it appeared. So it was obvious that in that game, the thing to do is to bet on numbers that are rather rare, and well, you just concentrate on the numbers above 5, and you make out a little better. And so I analyzed this thing statistically, and it, well, one newspaper man found it, and he says he doesn't think that it's a good idea for the government, that's I forget which branch of the government was sponsoring that research, to sponsor research in how to beat the lottery. But he had to admit that I came out with the winning numbers and told them that if you want to bet on those numbers. Actually, that was the first few hundred numbers, and after a while, the public got aware of what's good numbers and what are bad numbers, and they didn't bet on the bad numbers. They bet on the good numbers more than.
Did you find out why the numbers were skewed like that?
Oh, the numbers that came out were random.
Yeah.
But by random, the assumption that because there are 10,000 such numbers, you would rarely have a number appear twice was wrong. It was wrong. So the guy at the lottery, the official of the lottery, corrected himself later on about this thing. But later on, that lottery did have something wrong with it. They decided when the lottery reached a certain level, they would distribute all the money that was entitled to the winners. And so some people were very clever, and they waited till it was close to reaching that level, then they would bet, and they would make a lot of money. But that lasted a short time. And I didn't find out about it until much too late.
What were there any
One,
Were there any papers you worked on?
Oh,
over your
yeah,
career?
there were-
Not to do with
there
the
were a couple
lottery.
of groups that bet several $100,000.
No, not to do with the lottery, but were there any other papers that you really felt proud about during your career?
I didn't feel sad about it.
No. Were there any other research papers that you felt proud about during your career, that you were proud of?
Proud of.
Yeah,
Oh, yeah. There were other papers. Oh, yes, I wrote a paper on how to judge multiple choice questionnaires. A
Hmm.
multiple choice questionnaire, you get it right and you get full credit. You get it wrong, you get no credit. But if you have a class of 3-year-olds who are taking Spanish and they take a question, a thing for multiple choice, some of them know the answers and put down the correct answer. Some of them don't know the answers and they guess. So if in a true-false questionnaire, if 50% get the right answer, you can assume that no one knew the answer in this question. Everybody was guessing. If in the true-false questionnaire, 90% get the right answer, you can assume that about 90 or 85% know the answer and the others guess. And so you can grade them accordingly. So this is a sort of simple example of statistics in action. And it's a nice thing to talk about if you're talking to high school students. But the high school students object. They say, if I'm in a class with a lot of stupid people, I'm not going to get credit for what I'm doing.
Hmm.
So it's not really a sensible way to approach this thing. Dave Finetti, the Italian who worked on Bayesian theory very long before, because he goes the only logical way, he told me that's not the right way to do this thing. What you should do is ask each student to give his prior probability for the right answers. So if there are 4 possibilities, he could say 0.7, 0.2, 0.1, and 0. And then there's a reasonable way to evaluate that score, 0.7, 0.2, 0.1, 0, in terms of what is the right answer. And I said, but my students are 3 years old. My graduate students hardly know what probability is. Well, how will they know what probability is? Well, his answer was, give them 5 stars, and tell them to distribute the 5 stars among the answers.
Hmm.
They're very sensible answer.
Yeah.
So, are we reaching the end of the line, or is?
Yes. Thank you so much again for your time. I'll now hand things over to Brownie for our presentation. Thank you again very much.
You're welcome.
Yes, thank you, Anirban. Dr. Chernoff, thank you very much for your time and for showing us how statistics was done some time ago. And these all people that you listed are very well known, and it was pleasure to hear about.
Yeah.
I would like to say something about this Parzen Prize that we are giving you today. This was established in 1994 at Mani's 65th birthday. And he defined that this prize should be given to somebody whose innovation is such that it is between the core theory and the outreach practice, so that contribution is bought, as your research is. The committee for this award is elaborate. We have 3 members inside of the department and 2 members outside of the department. Some of them are previous winners of the award. I would like to list very briefly some of the former recipients. They are Grace Swaba, Don Rubin, Brad Efron, C.R. Rao, David Brillinger, Jerry Friedman, Alan Gelfand, Nancy Reid, Marvin Zellen, Adrian Raftery, Trevor Hasty, Bill Cleveland, and Bean Yu. And we are really proud to add your name to the list of these distinguished people.
Thank you.
In conclusion, I would like to add one more thanks to you. The Parzen Award also comes with monetary award with honorarium. And let me inform everybody that Professor Chernoff kindly donated his award back to the Emmanuel and Carol Parzen Prize for Statistical Innovation Fund. And this is a very nice gesture. Thank you very much, Professor Chernoff.
You're welcome.
And last, by being unable to present the plaque to you in person, I would like to show this plaque that we are going to send you by mail.
It's nice.
Oh, very nice.
And it says that Statistics Department of Texas A&M University honors Dr. Herman Chernoff as the recipient of 2022 Emmanuel and Carol Parzen Prize for Statistical Innovation in recognition for his outstanding and innovative research contributions, which have had significant impact on practice, October 7th, 2022. Thank you so much. And I'm back to Anirban for conclusion.
Am I supposed to say something?
Wait, they have some more to say.
Well,
No, so if you'd like to say a concluding word,
Yes, do you want to say something to conclude?
no, I thank you for the plaque and the award, and the people you mentioned were first-class statisticians, and I think it's a great honor to be included with them.
Yeah.
Thank you very much, Dr. Chernoff.